It is the term of the week. A bomb cyclone, a cyclonic bomb, Bombogenesis. Yeah, we have heard so much of this term over the last couple of days. Did you know that a Canadian man is the person who coined the term Bombogenesis, which is a mid-latitude cyclone rapidly intensifying, dropping at least 24 millibars over 24 hours? But he also is sorry he ever coined the term. He joins us from our Montreal studio live right now. Good morning to John Jackham, a professor, chair, Department of Atmospheric and Oceanic Sciences at McGill. Good morning, sir. How are you?
Good morning to you.
You are the bomb, sir. Is it true that you kind of like regret that term ever making it into the public lexicon?
Well, I don't think so, actually. When we first published this paper back in 1980, and the title was The Synoptic Dynamic Climatology of the Bomb, my advisor, Fred Sanders at MIT, had actually used that term for the previous 20 years or so. So the term coined as a bomb was really used quite extensively in the hallways of the weather forecasters at MIT, even decades before that paper was published.
Why?
So in some sense, I'm not too concerned about the use of the term per se. I think it's helpful to alert stakeholders to some of the dangers of these very extraordinary systems.
Is it a literal term? Is it actually some sort of a bomb? How did bomb factor into this, the word bomb?
Well, it was basically, I think, an easy path to take from the terminology of explosively developing cyclone. This is when a cyclone, as you pointed out, develops at a minimum rate of 24 millibars per 24 hours. And that's actually normalized for the latitude of Bergen, Norway. And if we, for dynamical reasons, we actually can utilize that metric for lower latitudes. And we see that this morning, for example, or yesterday, the extreme storm that we see off the east coast of North America was bombing out at probably nearly 4 times the rate of a minimum threshold bomb. So this is what we call a super bomb this morning.
You've been watching this one develop, and it moved rapidly up the east coast. What is your, tell us a little bit more about this latest system that we've been watching this week.
Well, I think what's extraordinary about this particular event is that it deepened so rapidly at such low latitudes offshore of the Carolinas yesterday. And what's interesting is the cold air. Of course, you've been talking a lot about the cold air in Canada, but as well, the cold air penetrated to as far south as Florida. Tallahassee, for example, Tallahassee, Florida was getting measurable snow for the first time since 1989. So the penetration of the cold air to lower latitudes is a big factor in facilitating this bombogenesis at such low latitudes.
Are we going to see?
Like I pointed.
Yeah, go ahead. Sorry.
Like I pointed out before, this was really an extreme bombogenesis. As you indicated, it's up in New Brunswick right now, but much of the important deepening occurred yesterday morning.
Are we going to see more of this with climate change, do you think?
Well, I think there's 2 aspects to this. First of all, the impacts, I think, are going to be much more significant, simply because of the fact that the sea level has risen over the years because of global warming. And even an ordinary storm, say 50 years ago, would have a much bigger impact today because of the fact that the ocean levels have risen. The second part of this is that the condensation heating that is associated with these bombogenesis, this is primarily an ocean phenomenon during the winter, that latent heat of condensation acts to fuel these systems, and that's going to be increasing in the future. So yeah, I think we have a good chance of seeing more of these systems occurring with climate change.
So yet another warning to us from Mother Nature. John Jackham, thank you very much for talking to us from Montreal this morning.
Thank you.